This is a very small database project, the purpose of which is twofold. First, we show the differences between databases and spreadsheets, but then we show how a properly designed spreadsheet table can be used in a database. The database we're using is Access, Microsoft Access, and since this is part of Microsoft Excel class, obviously the spreadsheet that we're using is Microsoft Excel. So we need to get the files, which we already have. The Access file is called Department of Transportation, although it will deal with the tasks usually accomplished by Department of Motor Vehicles, but that's the file that we have. To understand what we're doing, we need to recall that databases are used by business organizations and also by the governmental organizations, which have business rules and operate just like regular businesses do. So the purpose of the database in any organization is to automate flow of information. Before we start designing the database, we should know what tasks any business or government organization will need this database to automate. In this particular case, it's a very simple and small database. We say that the purpose of Department of Motor Vehicles is to track cars and their owners. And for that purpose, certain business rules are used. We know very well that each state issues its own driver's licenses, and all these driver's licenses have unique numbers. Therefore, each person that gets a driver's license in a certain state can only have legally one driver's license. But we also know that anybody can have more than one car. It's not infrequent, so these are the simple rules we're going to keep in mind. And we also know that the employees in the department look up drivers' last names all the time. So we know it's a frequent task because people come and go every day. So we'll have two tables in this database: owners and autos. Okay. We're going to open the owners table. Okay. I have increased the font here to size 16. One of the first things you notice when you look at spreadsheets and databases is that formatting is not as easy in the database as it is in the spreadsheet. Now, what do we have in the table? We have owners' names and everything else that the department needs to know about the owners: the driver's license and the address. You may notice here that the rows in the database are not automatically numbered as they are in the spreadsheet. Database designers know that, and they frequently, but not all the time, they frequently insert a separate column to number the entries. We may do it later, but right now we're not gonna need it. Okay. So, as you look at this table, you can tell that driver's license number is that very unique identifier which can identify every driver. Now, we talked about the tables in a database and the differences between databases and spreadsheets. The next difference, actually, it should be discussed first, between the two types of packages, is that in a database, each table must have an identifier. Tables in the database of the type that we're exploring are supposed to be related one way or another. If a table does not have an identifier, it cannot be related to anything and therefore will be called an orphan table. That is the useless table that only takes up the resources, storage space, but doesn't do anything. So each table has to be identified uniquely, and in our case we already have a fairly good idea what can uniquely identify the table which contains car owners' names and driver's license numbers. Next difference: when we design a table in a spreadsheet, we do it without going anywhere in the spreadsheet. We simply populate the table and assign all kinds of properties to the data that we enter, and we also do a lot of formatting. This is not the case for the databases. To design or change the design of a table in a database, you have to go into the design view. So on the Home tab, we find the View button and click on Design View. Now you see how the fonts changed. The font is less legible. There is a way to change it, but we won't do it right now. We now see that, just like in the instructions, the fields of the owners table are listed vertically, not horizontally, as we are used to seeing the fields in a spreadsheet or in a sheet view of the database. So we verify that we have our 7 fields, 1, 2, 3, 4, 5, 6, 7. Okay, they're listed vertically here because this allows for faster table design. We just spoke about a unique identifier for the table that we're looking at, and that will be the driver's license. So that unique identifier is called the primary key. The primary key is the column which will allow us to relate the tables, in our case the 2 tables, and in the primary table we're looking at, that will be the primary key. The table with which it will relate, it will be called, that same column will be called a foreign key. Okay. We assign a primary key by simply clicking on the primary key button in the Design tab. Okay. Now you have a little icon appearing here. The table owners has now acquired a unique identifier, a column titled DL number. Next, we just talked about the need for the employees in the Department of Transportation to look up frequently drivers' last names. In large databases, it may take a long time to do such a lookup. Therefore, a special smaller table could be created for that particular field, for owner's name. And that small table is called an index. This is the button in the design, under the Design tab, called Indices. Okay. There is one more rule for us to remember. We just talked about having to look up owner's name very frequently. And also, second rule is that there may be duplicate values in this column because there are a lot of common last names. I don't have to mention the name Smith. Everybody knows how common that is. So that's one of the reasons owner's name could not be the primary key. So we click on the Indices button and we have the dialog box which now shows the primary key that we have assigned to the table, and we also leave other properties as they are, but we have to do it thoughtfully and consciously. So it's not a primary key, we know that. The field name should be the owner's name. Okay, so we'll just call it owners. We know it's not the primary key, and it cannot be unique all the time. If there are several people whose last name is Smith who need to have driver's licenses, they should be able to get them. And the nulls we will not ignore. A null is a type of entry which does not have any data in it but holds up the cell. So we cannot tolerate that in a database because it will suggest that there is someone with a driver's license but without a name. So with this being finished, we close the dialog box and thus create an index for our table. We can now go back to the datasheet view. We have to save the table first. Now this is the same table, however, it has acquired a primary key and an index. That's the difference between the table that we have now and the table with which we started. We are also instructed here to sort the records in the ascending order, and ascending means A to Z, but down the page. So once again, the difference between ascending and descending, same is true for the numbers. 1, 2, 3, 4, 5 are the numbers listed in the ascending order, but it's growing in value. It's going up in value, but on the page it would be listed towards the bottom. So that's something to remember. Now we need to sort the records in the ascending order in database by owner's full name. We highlight the column, and on the Home tab we have the Ascending button. You may have noticed that all records have been sorted automatically as the owner's name was sorted alphabetically. Excel would not do that. Excel would ask you if the adjacent data, the data adjacent to the column being filtered, should be filtered in the same way. So in the database, this is automatic. We can now save the table. We always have to save before moving on. Now we only have, so far we have had one object in our database, this very table. Next task will be to create a form which will be used for data entry, and we'll do it in the next video because it's a separate task.